Thank you,
Yes, I
Messi.
can. I
Okay,
can.
okay, thank you very much. Okay, so good morning, everyone. So my presentation today will be um, introduction to Kubernetes and its architecture, the engine behind modern application. And very shortly, I would try to use a storytelling approach, right? So that regardless of anyone's technical background, you can be able to grasp the concept of Kubernetes, right? So my name is Akintayo Tolani Promise, and I'm a cloud DevOps engineer. So let's go into what we have for today. So let's take a scenario, right? I think the first thing we should look at, what's the challenge of modern, just a minute. Victoria, how many minutes do I have? Sorry, 20 or 40 minutes. Hello, Victoria, are you there?
Yes, I can hear you. What did you say?
How many minutes do I have? Do I have 20 or 40 minutes? So I can
Yeah,
work
you
with
have
time.
to. You'll be stopping at 9:40.
9:40. Okay, that means I have 30 minutes. Okay. Thank you very much. So let's take a scenario right here. The challenge of modern application, because for us to go into Kubernetes is actually a wide topic and we can't complete it today. That's why it's an introduction. But why do we need it? We need to understand this, right? So there's a challenge with modern application deployment. So on my screen, I can see number one, we have the scaling issues. So imagine you are a developer, right? I think most of us here, some or most are developers. Imagine you're a developer at a fast-growing startup. Your application is gaining popularity, and but managing it across multiple servers and environment is turning into an headache. Every time you deploy something, something goes wrong or the system performance drops. I I think we can be able to understand the perspective here, because when your application begins to get more popularity, people begin to find value from what you, okay, okay, from what you are giving, right? Your software begin to get many requests from your customers, and that begins to that's a load on your server, right? And you want to scale up, you want to accommodate more client, more customer in quotes. Doing this manually is going to be a lot of headache actually. And that is well, as you can see, number two says a need for a solution, meaning you need a solution to handle scaling, update, and resiliency without constant manual intervention. The key here is that we're trying to limit the manual intervention, because as human beings, we are prone to making mistakes. So when you are doing things manually, among the many things that happen is that you can't be able to track what you've done before. Number two, you are prone to errors. So we're trying to limit this. And that is where Kubernetes comes in. It's like an air traffic controller for your application, ensuring that everything runs smoothly. So there's a picture right here to give us a perspective of air traffic controller. Just imagine you are, just look at the picture. That will give you a perspective. The guy here is trying to, monitor and manage every single aircraft flying uh, around, actually, just trying to manage them, trying to know their altitude and all of that is a lot he's doing just in one place. So that's really what Kubernetes does, right? Okay, let's move to the next slide. Okay, here's another scenario again to help us understand what Kubernetes does. So Kubernetes is a container orchestration platform, actually. It's an open source orchestration platform, right? So you can see a picture right here. This is like a conductor here. So I'll just read through this. I would like us to just follow. The picture here, the picture Kubernetes as a conductor in an orchestra. Each container is like a musician that plays a part in your application, meaning the symphony. So just imagine, I think most of us have watched, various content whereby you see uh the the orchestra here, right? And everybody's playing their own part, violin, different instrument, and they are making one sound together. So picture Kubernetes in that sense. It ensures that every container is in sync. And I would like to explain what container is for people that do not have any prior knowledge. So container is basically your application running. That's it, your application running. So when you have multiple, or because like in real time, right? In real time, you can have thousands of your container running because you're trying to manage multiple, or just take for instance, let me give you a perspective. Take for instance, we all use apps like TikTok, uh, WhatsApp, and many other applications like that. And we know millions and billions of people are using the same application, the same platform. So imagine how much work is put into this application to make sure that it is stable, it is resilient, and we don't have any downtime, right? So it tells us this particular platform, they use Kubernetes to manage all this that I'm speaking about. Because you can't do this. It's different from when you just have a hub that you develop yourself and you just develop yourself, you are sharing it to your friends. That's just simple. When it comes to a larger application, it becomes more, it becomes more workload to be able to manage it. And that is what Kubernetes comes in to do. So Kubernetes ensures that every container is in sync. That's your application, your running application that is scaling up and scaling down as needed and replacing faulty ones without missing a beat. Okay. So what is this trying to explain here? Talking about scaling up and scaling down, right? So it means that, for instance, let's take, for instance, during the festive period, December period, people buy things a lot, they shop a lot. So let's take Jumia as a platform, for instance, now. So Jumia platform, we know Jumia, I think we are more conversant with that. You want to buy something on Christmas, on December period. So not only you is trying to buy something, many people around Nigeria are trying to get something on that particular period. So that particular period is people buy more things on that particular period compared to other period of the year because it's a festive period. So you tend to get more load, more customer requesting services from your application, right? And at that point in time, you have to have a mechanism to be able to scale up and scale down as needed. So when there are more requests, you scale up, and Kubernetes does these things for you automatically. You don't need to manage it. You just need to have set it down, then it does it automatically for you. It scales up, and it scales down when there are less customer requesting for your service. So automating application management, Kubernetes automates the deployment, scaling, and management of containerized application. So you see the same thing we are still explaining. Automating, scaling, and managing this containerized application. Doing this manually is a lot of stress, right? It's a lot of stress. So then moving to the next slide here, we have uh, behind the scenes Kubernetes architecture. So the topic was Kubernetes and its architecture. So we want to look at the architecture of Kubernetes. What are the components that makes up this platform, this open source platform we're trying to talk about? So the first thing here is Kubernetes architecture. It refers to the framework that orchestrates containerized application across a cluster of machines. When we talk about a cluster is a bundle, a bunch, and the machines we're talking about here is virtual machines, servers. So we can have like 10 servers, 20 servers, depending on what you are working on or depending on the application you are working on. So ensuring scalability, reliability, and efficient resource management. These things are very important. If you have an application that cannot scale, then what's the need of having it? Because um, we are building a software so that people from different part of the world can be able to access it, right? So if you can't scale, then is you are limited basically, probably to your own confines. You are limited, and if it's not reliable, people won't trust you. If people, for instance, now in a way, every one of us is sure that when you enter, let's say Twitter or WhatsApp now, you are so sure that it's working fine. You are not thinking that there will be an issue, even though sometimes and very little time there used to be an issue, right? You won't think that there will be an issue because of how reliable they have been, because of how reliable their system is, right? And one of the things here is Kubernetes, right? And efficient resource management. So I would like us to look at this diagram we have here. Is a diagram that explains everything we're going to be talking about today. So if you look at here, you see Kubernetes architecture, and looking from here, you see the UI. This is user interface. So Kubernetes has a user interface, right? Right. Even though it's not commonly used, but yes, that's a user interface because more work is done on the command line. And we have the CLI. Here is a command line interface, basically where you run your commands. If you have Windows, you have command prompt, things like that, PowerShell. For Mac, you have the terminal. So yeah, CLI, that's what it means, command line interface. We have the kubectl. And then here you have the Kubernetes master, right? Kubernetes master can also be called the control plane that we have here, the control plane. So it's also called control plane, Kubernetes master. And you have the worker node 1, worker node 2. So in real time, you have more than two worker nodes, obviously. Two worker nodes, but it's just to give us a representation, right? So the control plane is the Kubernetes master. And from our presentation here, you can see that the control plane is a central management entity for Kubernetes responsible for making global decision about the cluster and maintaining the desired state of the application. So what does this mean? It basically means that the Kubernetes master or control plane, yeah, is like the administrator, right? It manages the worker node. It tells them what to do. It's what do you call it? It ensures that the desired state of the application is met. So if you, let's say you, for instance, you design it such that you should have two of your application running at any given time, the Kubernetes master or the control plane will make sure that that happens. Even though sometimes one of the application can die, it will immediately bring up a new one, right? Things like that. Just think of it like an administrator. Think of it like a conductor in an orchestra. Think of it like the guy earlier we saw that was in the air traffic controller, right? So the next thing we have here is nodes. So the nodes here are just basically the worker node 1, the worker node 2. They are just basically virtual machines, right? That are managed by the Kubernetes master. So just think of it like that. So they are worker machines in a Kubernetes cluster that run containerized application. This is where the real work is being done. They're the one that handles a containerized application. The Kubernetes master manages them, right? Okay, let's move on. So you can this diagram is very important when explaining everything that we'll be doing here. And if you look into the worker node 1 as well as the worker node 2, you will see that we have containers. We have a pod. Then inside a pod, you have different containers. We can have 2, 1, 3 containers depending. And you can see that we have some other things like kubelet, kuprosi, docker, right? Those things are not the point, or let's say the focus of our presentation today, but just to take note of them. In a pod, you can have a container. So a pod is just basically a house for your container. It houses your container basically, right? So you can see you have the Kubernetes master, also called the control plane. You have the worker nodes. Yes. And okay, let's go on to the next slide. So here we have the Kubernetes control plane because we need to understand what it is, what are the components that makes up the control plane. And looking from here, the picture we have here, you can see we have the kube API server, we have the kube scheduler, we have the etcd, we have the cloud controller manager, we have the kube controller manager. So I will explain what this means. So the first thing we have here is the API server. And the API server here is a gateway, sorry, is a gateway to all cluster operation processing and validating requests. Let me explain what I mean, right? Let me go back to the previous diagram. So what we have here earlier is this. The API server you see here, because we have like 4 main components of the control plane or the Kubernetes master. The API server is one of them. So the API server is like the entry into the what? Into the cluster. So for you to be able to talk um to the control plane and also to the worker nodes, you go through the API server. So when you go to the command line and you just run a command, right? Run a command, the API server receive your request. Is the one that receives is the entry into the cluster. As you can see, the gateway into the cluster. So if you are trying to, let's say, scale up, if you are trying to bring down your containers, your application, if you are trying to increase the number of pods you have, doing a lot of things, the API server is the one that receives those requests from your commands that you put into the command line. And then we have the scheduler. That's the second thing we have in the control plane. The scheduler does something. It assigns, from the name scheduler, it schedules. Think of it, just don't make it complex. Just think of it, a scheduler. It assigns pods to node based on resource availability and policy constraint. So permit me to go back to the former slide. This picture quite explains a lot of things. So we have the scheduler here. When, for instance, you go to the command line, which is the kubectl, and you run a command trying to do what? Trying to increase your you have one container, trying to increase it to 2 because you want to make your application more available. So when you do that, when you run that command and click enter, the API server receives that request. And then the scheduler looks for the worker nodes that you have. For here now, we have 2 worker nodes. It checks these 2 worker nodes. It checks their resource availability. It checks, can this worker node 1, can it handle the what do you call it, the pod you are trying to deploy? Can it handle what we are trying to do? If it can, then it schedules it. It gives it gives the worker node 1 that particular operation, right? Pods are basically what do you call it? Your containers. You can see from this diagram, they house your containers, right? And if you can see, for instance, let's say this particular pod 1 now, it was not here earlier. So that we need 3 container running. You enter your command through the kubectl for this particular worker node based on the resource availability. If it does not have enough resource, it will look for another worker node to give that particular operation. Then the controller manager does something else also. As you can, I think the name in a way explains a bit of it. It maintains cluster desired state by managing different controllers. So a simple example is, let's say you want to have 2 containers running every single time, no matter what. So the container manager will make sure that 2 containers are always running, no matter what happens. Even when one of the container goes down by whatever reason, it will immediately bring up a new one to make sure that that desired state is accomplished, right? That is what the controller manager does. And then the etcd is a very important component. It's basically because it's basically, you can call it a database, right? It's a key value store that stores your cluster data, including configuration and state information. So I will explain something how these 4 components work together very quickly before we move to the next slide. So when you run a command, right, the API server gets your command. Okay, you are trying to do this. You are trying to make sure that 2 containers are running every single time. Okay, then the etcd stores that information, stores what you are trying to do. When it stores it, the scheduler looks into the etcd to try to see what you want to do. Okay, you want to make sure that 2 containers are always running of your app. Then the scheduler looks and then schedules it. It looks for any worker node that has that resource availability to handle that request. Then, for instance, if worker node 1 has that availability, schedules it for it. Then the controller manager now begins his work from that point. It makes sure that since we said 2 containers should be running, then 2 containers must always be running, irrespective of what happens. Even when one container goes down, it brings up another one immediately. So that is that's about that. So let's move to the workforce. I call it the workforce, the Kubernetes nodes. Like we saw earlier, the worker node 1 and the worker node. So these are where the work goes on mainly. What the control plane does is just to manage these worker nodes. The worker nodes are virtual servers that have been configured to communicate with the Kubernetes master. So from here, the nodes, it says the nodes are where the reaction happens, executing the tasks assigned by the control. So the control plane is like an administrator. It assigns tasks to different worker nodes and make sure that they get that task executed, basically. So you can see from this diagram here also, we have a master here, we have various worker nodes. In real time, you can have 10, 20s, even more than that worker nodes, right? So these are where the work happens. These are where everything happens. What the control plane does is to assign tasks. And we have pods. Pods, these are just terms, right? Terms. Pod basically means each node is responsible for running a pod, which houses your container application. So I, I can go back to the diagram we have here. So this is a pod here. It houses your containers, different containers, right? What we mean by pod? They are inside your worker node. Yes. Okay. And then, okay, let's move now to a real world scenario. We've been discussing about different components. Let's check out a real world scenario of how Kubernetes in action. So take, for instance, imagine you have a popular online store. Let me give you a perspective. Think of Jumia, Alibaba, and any, any online store like that you know of that is very popular. So this online store here now experiences a surge in traffic during a big sale. So let's say probably Black Friday or festive period. More traffic are coming into your application. More customer requesting for services. They want to buy something. They want to do this and do that, that kind of thing. So yeah, but let's say on a normal note, you have like 100 of customers on a daily basis, but on this particular festive period, you have like thousands of customers. So how do you manage this, right? Then what Kubernetes does is that if Kubernetes is integrated into your application, it automatically scales the application to handle the load. So it increases the capacity of your application to be able to handle these loads, because formerly you have 100 customers accessing your application, but now you're having thousands because of the festive period. It will scale up to handle the load, make sure that your application is accessible, and then everything is working perfectly fine. Then we're talking about scaling down. So what happens when the first period is over and then you are back to 100 customers per day? So when traffic drops, number three, Kubernetes scales down, saving resources. So it will scale down because when you scale up, you have more storage, more CPU, more resources basically. And these things are cost in a way. They are cost. They will cost you. And so when there are no more when the customers or the client requesting application goes down, Kubernetes will drop. It will scale down, saving your resources. So this is cost management you have here. And the last thing here is number four, high availability. Even if a server crashes, let's say one of your worker nodes goes down, the control plane ensures that a new one takes the place without affecting your customer. Within matter of seconds, minutes, another one is up without you being there, because you have configured everything to work just like that. So this is what Kubernetes brings to the table. This is how, in a real scenario, obviously there are different um, case scenario, but this is just one to help us see how Kubernetes can help us. So the power of Kubernetes, just to give a quick summary, the first thing is, among many other things, is the simplified application management. So Kubernetes simplifies the deployment, scaling, and management of your application. And number two is the resiliency and the scalability of the architecture it gives to you. So the architecture ensures that your application is available every single time available, resilient, to be able to handle load, able to handle requests coming from your client customers, and scalability, can scale up and scale down, saving you cost, being cost efficient, right? So I hope I've been able to give you a perspective using different um, explanation like the conductor and orchestra, the air traffic controller, and explaining these terms um, to help us to be able to understand what Kubernetes actually does. Yeah, in a very simple term. So right now I'll be pitching questions to the audiences, right? Before I accommodate questions as well. So the first question we have here, just have only two questions. The first question we have here is, what is the primary function of the control plane in Kubernetes? We've been explaining about control plane, the Kubernetes master. So the options here, we have four options. Anybody can answer from the audience, right? To run containers and manage network traffic, to store application data, to manage and maintain the desired state of your cluster, and then to expose application to external user. So anyone from the audience can please answer the question, question one. Anyone from the audience?
Yeah. Option 3.
Option 3, that's Mr. Samuel. Okay, yes, yeah. The control plane manage and maintains desired state of your cluster, right? Yes, that's what it does. Hopefully in the next, or let's say upcoming presentation, we will dive deeper into these things because it takes time to understand every concept. So question 2, what is one of the primary advantage of using Kubernetes for managing application? So one of it is the option 1 here we have is automated scaling, manual configuration, limited availability, single node operation. So I would like to call on someone to answer this. Okay.
The answer is 1, automated scaling.
Okay. Yes, automated scaling. Thank you very much. I was about to call someone else, right? Yeah, thank you very much. Automated scaling. That's one of the things that Kubernetes brings, right? When it's been integrated into your infrastructure. Okay, questions and further discussion, right? Is there any other question from the audience based on the presentation? We've discussed a bit, right? If there's any question you would like to ask, it's time for question. And also, yes, time for